and let's say I want to give an align dimension or a linear dimension. I can take here. So if I want to give, so this is and here I can move this text, and here just put the cursor over here, so move with the leader, so just put the ortho off. So here you can edit the text, and you can see that stirrups at the rate stirrups, or you can say at the rate 250 spacing, or whatever the spacing you have. So here you have 6 dia ties at 200 center to center distance. So you can write that at the rate 6 dia ties 6. So dia symbol is 6% C, 6 dia at the rate 200 center to center. So 200 means 200 C, oblique C. So this can be written like this with the multi-leader, and similarly you can have different multi-leaders giving showing. So this is not a multi-leader, this is a leader along with the dimension that you have shown. Similarly, if you want to give this as a for example, how many of the main bars are there? So here we have got around 6 main bars. You can see 1, 2, 3, 4, and they are basically the main bars are 16 diameter. That means there are 6 in numbers, and you have got the diameter is 16 So you can use the multi-leader, and you can always have, let's say I will go for a nearest snap. So here I have the nearest snap. So nearest snap will help me to point it somewhere here. So I just mark it here, and I say, so I would say 6 numbers. That means the main steel is 6 numbers at the rate, let's say and the dia is, let's say, not the at the rate, 6 numbers are there, and I would say that it is 6 numbers 16% C, or you can say 16 dia. So it shows that you can increase the text size. So here we can have the value whatever size you want to give the text, or you can change it from the style. So this is how you can dimension with the leader. Let's suppose you want to add more leader, so you can always point here. So you can use that add leader option from here. So you have this add leader. So here we have add leader option, select it, and you can always point it here, or you can always use the ortho. So because it is a bit tilted, so I'm doing an undo option so that I will do it again. So you have a multi-leader, and let me go with the nearest option again, and so I click into it, and then I write a text, let's say 6 numbers 6 numbers dia is your 16 dia, 6 numbers 16 dia. So you need to write 6 numbers 16 dia. So you write a text over here, so it is understood. And if you want to show this to the other rebar, right, so you can always show it for example, you can go with the add leader, select it, and just use the perpendicular option, so that press enter or escape, so you can show that these are the main rebars and these are the stirrups. So this is how basically you can do the dimensioning of the reinforcement. And then if you want to show, these are the distribution bars. You can see that here we have the distribution bars, which is 12 dia at the rate 150 spacing. So you can always mark with them. So this is a distribution bar. I put the ortho off and give the distribution bar as, let's say, I would go for, it's given 12 dia at the rate 150 C. So this is something that then I can dimension the pedestal here. So I will put the ortho snap on. So here I have this is 1000, and so if I want to increase the size of the dimension, so what I need to do is go to the fit option and go to the scale factor. Let's say I would go for 35. So again, let me check. So set current. So the size will increase a bit, and so this is something that you should look forward for it. Then you have a dowel, you can do it, and if you want to show the cover of the isolated footing, so you can always show it here. So I'll show you some of the projects. Do the dimension in the project. So I have a detailed project that I have for the structure, so that we can apply the dimension there also. Now let us take another example here. This is basically a footing plan where you can see that the footings are placed in the grids, and the grids are dimensioned in continuous dimension. And here you can see that how the column sizes are marked, and they are have a C1, C2, C3 types, as well as the foundations. Like for example, if you can see this is the P1, P2, and then we have got the column schedule. So here we say the footing. Let's say if you want to understand about, it is an M25 grade, and we have the 25 dia. That means the dia of these bars is 25 mm, and we have got 12 16 dia bars which are not marked A, and the one's set of 5 stirrups. So you have got of the stirrups are 8 diameter, and they are center to center spacing is 8 inches. So you have got different kind of scenarios over here. So now let's talk about the columns over here. So now the columns is again, it is the stirrups are also there, and we have the main rebars of the columns. So columns we can look at over here. So this is the one of the column schedule where it says the size is 9 inch to 24, 9 inch into 24 inches, M25, and main reinforcement is 12 rebars are there. 12 rebars are there of 20 mm diameter, and the stirrups are these are the stirrups are at the spacing of 8 inches center to center, and there are two types of so 8 inches center to center, and dia is 8, right? So you have got two options over here, 8 dia at the rate 3 inches and 8 inches CRS, so different kind of center to center spacing. And then you have this another column. It shows about another column which is in the first floor to the second floor. So it is 12 16 dia, and M25 is there, so you have got 12 main reinforcement there. So they are of 16 mm dia. So this is how basically the dimensions and the texts are made. So this is a column, typical column schedule, and here you can see how the boundary wall foundation is dimensioned. So it is, you have got the stepped footing over here, then you have a DPC and the NGL, and so you have got a lot of feeder marks over here. So it says that you have this rebars in this concrete wall. So this rebar is the section EA is over here. So this is the 16 that is dia is 6, right? And 6 inches center to center distance. So now you can see that the marking has been done, and this is how the dimensions are done. Now you can look into the footing plan. The dimensions are made of the between the this is the footing, and it shows the dimension how much offset it is from the main concrete wall. So you have the section A. So this is how you make the column schedule, and in a structural drawing the dimensions are made. For example, here we have the grid dimension, then you have the spacing of the pedestal from the column. So this is for the feet inches. So if you want to so here you can when you go for a dimension style, you can have different types of dimension style. And let's say I have a dimension style, I can create my own dimension style, and then I can have different patterns I can give it to it. Let us look into another drawing over here. So let me open up the so you have this floor plan. Okay, you have the isolated footing, and this is again the beam. So this is how it is shown with the leader. That is, three reinforcement are there at the rate 20 mm, at the rate 20 inches. So these are so 3 dia 20. That means there are 3 reinforcement of dia 20 as the main reinforcement. Not spacing is there. Dia is 20. So again 20 dia at the top. So it's the top reinforcement. Then you have the bottom reinforcement of the slab. And then this is of the beam, which is B15. So this is the detail of the B15 beam, where you have the bottom reinforcement 3 of dia 16 are placed, and you can see that the main the stirrups are of 8 diameter, 2-legged stirrups. 2L means 2-legged stirrups at the rate 4-inch center to center distance. So you can mark them, you can dimension them with the help of the multi-leader, and you can always use all types of dimension techniques like the leaders, like the dim linear and other things. So this is the part I wanted to explain you here. Now let us do a bit of practice with how to create elevations. So I have this floor plan. So just wanted to give you a 10 minutes demonstration of how elevations can be created. So and then we can dimension the elevation. Now I look into it. So there is this is the front elevation, front of the plan. So I want to create the elevation, which is G plus 1. I mean only one floor is there, and let's say I want to create the elevation. The way I would suggest that you can create an elevation of a plan is by projecting it. Now elevations we always see from left to right. So if you are looking from this side and you want to take the elevation, the front elevation over here, so go with the Xline command, and you can have the projection here, and so this is the maximum projection that you can have. And then you can have a horizontal line, let's say. So this line will represent the I would suggest that this line should represent the FGL, the finished ground level, or the natural ground level. You can also have the natural ground level. So this is, so if you want to have a plinth of 600 mm, so we are using, so now let's say if I want to go, we are using millimeters, so I want to have a plinth level at 600. So I give a value of 600, and then I can take 600 as, and then the sill level is at, let's say, 900 mm from the plinth level. So this is the sill level, and the lintel level, it is the 2100 from the plinth level. So I'm marking all the levels, and height of the building is 3300. So so 3300, and I'm marking the height. So this is the 1-story height of the building. Now you can trim this. Now this is the plinth level from where the doors and windows will mainly be measured from. So here we have some columns over here. So in the elevation, the columns is protruded outside, so you can have the columns over here. So you can take a projection of the columns over here. Let's say you can have the projection from here. So you can have the projection over here. So you have got this projection, and there is one projection here, and you have the projection of this wall, because there's an opening over here. And then first of all, let us go with the projection of the columns, and then we will do the windows and the doors. So let's say I have the projection of the columns. So now you can see that just trim this, and sometimes you want to have a look of the plan, and then you create the elevation. So let me move this entire unit a bit up so that I can coordinate with the elevation. Now here in the first, you can see a column is there, so you can trim this because it would be seen. Okay, so then you have this wall, then you have this column again, which is protected outside, so you can have the trim command over here. So these are construction lines. You can see that the others are. Then we will put them into a layers also later on. So then you have another column here. So you have this long cursor which is showing. So you can increase the cursor size if you want. So go for the trim and select the cutting edges, and you can have the cutting edges. So you can trim it. Similarly, you can, there's another column over here, so you can trim them. And let's say I go for the trimming option. So this is something that you have to make it practice to create. So trim. You can select all also, press enter, so that you can speed the trimming process. So you have this trim. So now the columns are seen now in the elevations, which is going to the height. So you can take a dimension for that. So you can have a dimension linear, and you can always measure the dimension. Let's say this is 3900. So we will be having the detail later on. So this is the column, and then you need to also show the window openings. So the window openings start from the cell level. So now let's project the window opening. So let's have the vertical projection. So here we have the window openings, and there is a chhaja which is a cantilever which is coming out. We have to show that also. So let's say I can trim this. I can trim this. So I'm trimming the whatever, and erase this one. And so this line is a hypothetical line, so you can have this line or you can erase it later on. So you have the window installed here, and another window is over here. So you can, so here you do not have anything, so you can erase this line. So there is a door over here that we'll be making later on. So you have this you can project the window, and there is a column here. So there is a window over here, and there is a opening, so you can have the window opening. So you can always go for a trim command, and here we go. So with this you can see that the window openings are made in the elevation. Similarly, if you want to, so all the windows are now made, so you can have the you can see that there are two windows over here. Then we will detail the window along with the chujas or the sunshades. So now elevation in the height. Now you would like to have the bin lane again. So you can see the height from the, let's say from the uh, sill level is 900, and from the sill level, so you can have a dim base, or you can always have a dim base, right? So that you measure it from the plinth level. So dim base. Sorry. Select this as a baseline. So this is 2100. It's a dim base. So you can mark. You can have this door later on. So now you have this plinth line. Let me not remove it right now because I may require it. So this door is having steps. So let us go with it. Let's say dim. So I'll go Xline. So I have this projection over here for the door opening. So Xline, we will go for a vertical line. So 1 and 2, and it goes to the lintel level. So I can use the fillet radius 0 to mark it. So if I want to trim this line, I can use the trim double enter, trim, press enter, and so you have this door ready. So the door will start from the plinth level. So there is, you have a, let's say, riser of 150 mm. So you can have a riser of, so it will go up, and you will be able to go inside the building. So let's say there is a repetition. So please undo. So now you can see that you can erase this line. So if you want to have this is the entrance to the opening, right? We can create the door, we can design the door, the panel door or whatever it is. So here again, now you can see the columns over here, and there's a wall here. And if you want to again get the projection of the door opening for the staircase, you can always have the projection. And let's say it starts again with this. So now something that you need to understand is the elevations are basically subjected to the design factor. So again, we have a 150 mm riser. So here in the elevation, the riser will be seen, and in the plan, the treads will be seen. Now you have 1, 2, 3, and 4 risers. Now you have to look into the plan. The plan is having 3 risers. So you have to increase one riser because now the plinth level is 600. So let's say I would, in the plan, I would like to make a change. So the tread is 230 mm. So here I go with the, so you have got, so the number of risers you're having 1, 2, 3, and 4. So in the fourth riser, you are basically going inside. So here you have 3 risers, so you can increase one, and always you can go for a fillet. And so this line is gone below this line. So what you can select this line, right click and draw order. You can always bring to front. So it is above. Now you can match the property of this line with this line. So your number of risers are 1, 2, 3, and 4. So it's now okay. So now similarly you can want to have so let me delete these lines because it's creating again. There is a line over here which is below the line, the main line. So you have to bring to front and add another thread so that another riser can be added. So this is the review plan as per the elevation, because the plinth level that we had taken is 600. So here you can draft it, and you can always have the tracking and draft the windows and the doors, sorry. So as per the requirement. Now, so what we did right now, so now there is a column at the end, there is the column at the start, and there is one window opening, 2 door openings, and another window. So this is the height from the top of the plinth beam. Let's say I can write as TOB from the NGL. So now you have got this particular, there would be the plinth level is there. So what you can do is you can mark an imaginary line over here. Let's say you can have it as a dotted line, so that you can mark this as a plinth level. So this you can go to the home tab and select a hidden line. So this is the plinth level. So you can have the multi-leader now place in action. So now you can write it here as so make sure that it does not crosses any dimension line. So press enter. So you can write it as plinth dash is 600. So these are the levels that you have marked. So this is the plinth 600, and then you can have this the top of the slab. So this is the height of the building from the. So this is the top of the slab, and then this height is generally this is the reference level. So this is an NGL you can write. So with the multi-leader, you can always mark it as natural ground level NGL, and here we are. Then you have the parapet. Let's say you have the parapet at you can say 650. So there would be, it will rise above, and so this is a parapet. If there is a single story building, so it will be having a parapet, and the elevation is now basically complete from the point of view of the levels. Now the columns will definitely go up, and probably this line will not come, and the reason why, because there will be a sunshade which will be there, because these lines, so this column will go up, and there is a sunshade that will be going throughout. So we can have another line over here, let's say at 650, which will be showing the sunshade. So this again, there's a 2 columns over here, 2 columns. So there can be a leading line here that would be showing the sunshade. So you have the sunshade placed over here. You can see a dotted line. So this goes from the column to the column. So you can have the sunshade at let's say 650 from the top. So, and the sunshade thickness is let's say 75 mm. So it can be let's say, or you can have a let's say 100 mm thickness. And so this is the line of the sunshade. Now this sunshade is protruding out, so the columns will be protruding outside the column. So the line will be major lines. So we have created the sunshade. Now you can see the sunshade is created. So this is a sunshade. So then we can also see that there is a projection over here. So the sunshade over here, the chaja is coming at the top at the height of let's say we can have the height. So this is the height of the sunshade from the NGL. So we can always measure the height. I can keep it here. So what I can do right now, okay, so I just take the dimension from the left. So let's say I keep the dimension from this point, and let's say from the, so this is, so the top of the sunshade is 3900. So it's already given over here. So just need to mention about this. Apart from that, in this elevation you can see that there are certain projections over here. So you can always have these projections. So let's say I take an XL vertical line, and I can have the projection over here. So the projection comes from the wall over here. So the projection starts, let's say, at the little level. So let's say if I, so just to develop the projection, so I do a trimming option. So I have a 75 mm thickness, and I can have a tapered projection also. Let's say if I want to have this at 150. So I can always have the projections mentioned like this. So this is the projection that is coming from the windows, right? So this is how you create the elevation, and then you can take the dimensions of the different elevations. So let's say if I want to develop a window, so the size of the window here comes, let's say I can have the size, I can show the size. So this is 1000, and the sill level is let's say from the 900 from the plinth level, but let's say it is around 1500 from the NGL. So I have this sill level marked here. So I go for a dim limb. So if I want to reduce the size, so you can see that the extension line size is increasing a lot. So because of the snapping point, so what I can do is right now put the snap off. So I can have dim limb. So you can see that the frames are created. Then we can have the panels of the window over here. So I take a midpoint from here. So if it is a double window, I can always have a, let's say, a 50 mm panel with a glazed. So this is just one sample of the window that you are seeing over here. So you can see that I am creating the panels of the window. The frames are created. So just see how the frames are created. So with this you can create, so extend it to the part. So you can create one part, and then you can always have the mirror option in the other part. So let me put it, so I'm doing a quick trimming of it, and then what I will do is I will mirror this panel. So I'm just taking the mirror of this, let's say select object. So I take this glass panel, and I can do a mirror by taking the midpoint as this point, and no. So you can see that one window is created, then of the particular size you can create more windows. Similarly, you can create the doors. Other things, so this is the way we create the elevation. And if I want to change, if I want to make size of different dimension styles, so I can have some different dimension styles. So I can have, let's say, elevation, and here what I can do is, here I can have different arrows. Let's say I can have a close flanked, and in the fit I would be going with, let's say, over a scale of 30, so that it looks a decent kind of elevation. So now let's say if this is current, so here you see there is an I have made in the dimension style, I have made this as current. So what I can do is I can update this dimension to the current style. So there is an option called dimension update, so you can find it somewhere here. So select this, and if you click on this object, you'll find that the dimension is updated to the current dimension. So let's say if I want to update this into the current dimension, so I can select this dimension and update it to the current dimension, or I can do dim update and update it to the current dimension. Now you can see the extension lines are staggered, so just you can pull them and get them somewhere. So this is something that is very important while you are creating elevations. And so here we finish the session 7. And another thing, if you want to have the let's say, you can use more tools in your plan. So we did some exercises like the footing, flooring, and other part. So next we would be also looking for more plans, and there would be challenges there that you can work. So thank you.